All right, number 14. Says, can wine tasters distinguish between more expensive wines and their regular counterparts? Of 855 random tasting trials, 346 resulted in correct distinctions. Use a 0.10 significance level to test the claim that fewer than 50% were successful. All right, so this is back to your hypothesis testing. What did I hit? This is from chapter 8. Let's see, on this one, looks like we are testing what are we testing? A proportion, which I found in 8.2 on page 17. We're going to give the value of the test statistic, the critical region, and the decision. Okay, so starting with the test statistic, my formula is p hat minus p over p 1 minus p over n. All right, so p hat is, let's see, in this case, looks like they've given us our sample size and our number that were correct. And I'm just going to write that as a fraction, 346 over 855. That's my p hat minus. Okay, p comes from the claim that we're testing, which they didn't have us write the claims. Let's see, what would it be? We're testing the claim that fewer than 50% would be successful. So I'm just going to write my claims here so I can see what's going on. P less than 0.5, that's what we're testing, which means my null would be greater than or equal to 0.5. Okay, so that helps. So P is 0.5. Okay, over 0.5, 1 minus 0.5 over n, which is our total sample size of 855. Okay, I plug that into my calculator and I end up with negative 5.57. So there's my test statistic. Then my critical region, so this one is one-tailed. Back to this null or alternative hypothesis, P is less than negative 0.5. So I'm going to have my R on the left side because it's less than, and my F on the right. And my value is going to be negative. And let's see, we're doing a proportion, so this is going to be a Z. So I go to table A3, one-tailed, so I don't need to divide anything this time. Let's see, 0.10 significance level is my column. That's the one all the way on the end. And because it's Z, we go to the bottom, and I've got 1.282. So negative, you do make it negative on this because it's less than 1.282. I'm going to go ahead and plot my critical or my test statistic on that. So that's somewhere on this end of the line. So that means my decision is to reject my null hypothesis. They did not ask for a conclusion, so we are done with part A. Okay, part B does say to check the assumptions. So there are 3 assumptions when you are testing a proportion. First, it has to be random. So looking through here, yep, I got the word random, good. 2, it has to be binomial. So to test it as binomial, we have some things we have to check. Fixed number of trials. Looks like yes, they tested 855. success and failure. So success would be, what are they doing? Correct distinctions. Failure would be incorrect distinction. Independent. And the constant rate of success. And we just kind of assume those two are true. All right, so all four of those things are true, so it is binomial. And then our third assumption, there has to be more than 5 successes and more than 5 failures. So we're going to say n p greater than or equal to 5 and n 1 minus p greater than or equal to 5. N was what 855. P is 0.5. That has to be greater than 5. Yes, that will be greater than 5. And then 855, 1 minus 0.5. Yeah, that's going to be like 420 something. So that's also greater than or equal to 5. So we're good on both of those. And do make sure that when you're working one of these on the exam that you do write all that out, because I'm going to want to see all that work there. Okay, so we have that done. Okay, so we have finished that problem. We've checked our assumptions. All right, last one right here. Says the height of a patient is useful for a variety of medical purposes, but it can be difficult to make an accurate measurement if the patient is confused, unconscious, or sedated. In contrast, ulna length measurements are generally quick and easy to obtain, even in chair or bedbound patients. A sample of patients had an average ulna length of 24.72 centimeters and an average height of 65 inches. Use a significance level of 0.05 to answer the following questions. And then there you've got a StatCrunch output that we're going to be looking at. So this is chapter 10. And I found this on page 9 of our last set of notes. All right, first it says give the regression equation. Well, that's where you go right here in your output to the column that says estimate. And it's y hat is 27.98. Let's do 9 plus 1.494x. That's just your slope and your intercept right there. Then it says find the best predicted height of a patient with an ulna length of 22 centimeters and justify your answer. All right, so again, this is where we have to check to see if there is a linear correlation to make predictions. And on this, I'm going to look at my slopes p-value, 0.0001, and I'm going to compare that to my significance level. Oh, it's not, it's less than. It is less than 0.05. Okay, well, what that means is we cannot plug it in. So what I'm going to do instead, read through my problem. Oh, here it is. An average height of 65 inches. So I'm going to say 0.001 is less than 0.05. So must use average height of 65 inches. And then B says interpret the 95% confidence interval given above. You do not calculate it because it's in the output. This is on page, you know what? This part right here was on page 4. And this down here was the part that was on page 9. There you go. Okay, so confidence interval is this right here. It says we can be 95% confident that the average height of a patient with ulna length of 27 centimeters is between where is it? 66.859 and 69.787 inches. So that's for the confidence interval. Now, not to give anything away, but if it asks for a prediction interval, remember that that's this part right here. And the only difference in the interpretation is that we would say, instead of the average height of a patient, we would say that the height of a patient. We would not say average height of a patient with ulna length of 27 centimeters is between 64.952 and 71.794 inches. So the only difference for prediction interval and confidence interval in the interpretation falls right there. We're not talking about the average height anymore. We're talking about just that one patient.